For this example, 1, 2, 3, 4, 5, 6, longest chain 6, so hexane. I didn't cover the substituent here, the methyl group at the third position, so it is 3-methylhexane. For this case, it is got 3-ethyl 4,7-dimethyl, no name because longest chain here I draw here. It is 9 carbon, and we have a 3-ethyl 4-methyl 7-methyl, and remember the letter goes first, so E comes before M. Remember this di, tri, tetra, we don't count them, so it's M against E, E goes before M, so it brings along the number 3, so 3-ethyl, then 4,7-dimethyl. Remember here we factorize it, the 2 methyl groups, so the numbers here, then put the di, 2 of them. Next case, 3-ethyl 2-methyl, again E comes before M of a hexane. Here we have a hexane right to left because the first branch point is of a lower number than the left side this way, so 4-ethyl 2,4-dimethyl, so again E comes before M, di because 2 identical methyl group that are on the second and the fourth carbon of the longest chain. In this case, heptane in black, just like Rebecca, it is 7 carbon chain, 4-ethyl 3-methyl heptane. Hope you understand why. I just see a pattern here. Number 5 here, the rule says name the branch substituents as full if it will compound itself. So if we have something called a secondary branch, so you see this is your main chain, these are your primary branch, and then here in your primary branch you have a secondary branch. You see, primary branch, you have secondary branch. So what we do is we focus here and we see, okay, suppose it is alkane. How do we name it? We call it 2-methyl propane, right? Propane 2-methyl. But now this whole entity becomes a substituent. So from alkane to alkyl, we'll drop the ane, we add the YL, become 2-methyl propyl. And then now we will count this letter. We will alphabetize the M, not the P. So together it will be a 2,3-dimethyl 6. Then we put a bracket here, not to confuse people because this number is for the inner secondary branch, 2-methyl propyl decane. So we are counting. So in this case, we are arranging them, comparing M against M, not M against P, okay? M against M. So M against M, there's no fight, right? So we go to the next letter and we see that, oh, it's the same, right? M-E-T-H-Y-L, M-E-T-H-Y-L, it's all there. So what do we do, right? So space would come before another letter, so space will win P because nothing. After L, there's nothing, so nothing wins something. So there are more examples here. I hope you understand why that these are the correct name. No name, try yourself. Longest chain 9 carbon, can't do better than that. Branching points, where are they? You have secondary branch here. Try to name this secondary branch. This is a 1,2-dimethyl 2 identical methyl group of a propyl group. So the first carbon that branches out is got number 1, 2, and 3. Right, this way, 1, 2, and 3. So these 5 outside the parenthesis would mean the 5th carbon of the original parent chain. So in summary here, we talk about the alphabetization in the naming of alkanes. The prefix indicates the number of identical groups that are not considered part of the alkyl group. So when we have dimethyl, 2 times of a methyl group, doesn't matter anywhere, 4, 4, 4, 6, 7, 11, right, convenience store, it will just be alphabetically listed under M. Remember, we do not count the di and tri because this describes how many of these groups are. So triethyl is under E. And remember, these are only for primary branch, and if they are further branching, secondary branch or tertiary branch, then the first letter count. What do I mean by that? Let's say we have a 1,2-dimethyl-butyl. So you see here from the name, it suggests a secondary branch. That means we would count the di, the D, okay, the D. Non-hyphenated prefix iso and nil are considered part of the alkyl group name when you alphabetize it. We see some example. isopropyl, isobutyl, neopentyl, neo the one. Then all these we will consider the I and the N. But remember, these are non-UPAC names, it's a common name. Okay. The last rule says the hyphenated and italicized prefixes sec and terp, they are not considered part of the alkyl group. So sec and terp, secondary, tertiary, we do not consider the S and the T. The butyl is a B, so it will be listed under B, the butyl, not the T or the S here. So be very careful. So now it's practice time. Example, what is the UPAC name of the following alkane? Give yourself some time and we'll go through later in a few seconds. Okay. The strategy is first to find the longest continuous carbon chain in the molecule and use that as the parent name. So longest chain, you have to try, see, is it starting from here 1, 2, 3, 4, 5, 6, 7, 8? Or could it be longer? Right. So if you do that, you find that indeed it's 8 carbon this way because the first branch point 2 is better than 3. Finally, you have a factorized dimethyl, so 2,6-dimethyl octane. Not sure? Please come and ask me. Next practice, we try to convert a chemical name to a structure. You have to be very well versed in both ways, seeing a structure, convert into name, given a name, convert into a structure. So draw the structure of 3-isopropyl 2-methyl-hexane. Always draw the longest chain first. That's my strategy and rule of thumb. Hex, 6 carbon, 1 row, and then you see label 1 to 6. The second carbon is a methyl group, single carbon CH3. The third carbon of the hexane, we have an isopropyl, so it's a equivalent branch. You take a Y, good Y attached to it, right? So these are my strategy in summary. So I will do that. See, branches out equally, and then in the end you add hydrogen to complete the structure. Of course, what I prefer would be the line structure, the skeleton model. This is what I desire and we will love it. Okay, if you give me this, yes, you get it right, but again, it's not very time saving, cumbersome, and there's a higher chance of getting it wrong because you might not have remembered to insert all the hydrogens. See, so many. So this is the structure of 3-isopropyl 2-methyl-hexane, and I give it the color coding so you can see longest chain and the branching. Now this I went through earlier, so just to repeat, alkanes shows very little affinity for other substances, super inert to major reactants, unless it's fire. When you have fire, oxygen, it will burn. It's a great fuel. Where parents or family or anyone go to the petrol station to put in some gas, so these are your octane, your benzene, your alkanes. So alkanes will be combusted in oxygen to give you a mixture of products, and if you have a complete combustion, that means excess oxygen, you have only CO2 and water vapor. And if you look at methane, it gives off a lot of energy. In fact, this reaction is exothermic. This doesn't mean endothermic. This means when it's burning, it also gives off 890 kilojoules per mole of this equation. That's a lot of energy, so we are using it as a fuel. The gas at home, you see, we turn, we cook, cooking some nice miswa. Well, we need energy, and the energy comes from alkanes, natural gas.